Imagine a world completely unrecognizable, yet it's the very ground you stand on. What if I told you Earth's earliest history wasn't a collection of scattered landmasses, but vast, mysterious supercontinents hidden deep beneath our feet? Recent breakthroughs are finally revealing these ancient giants and what they mean for our planet's incredible journey. Prepare to uncover the secrets of Earth's truly ancient crust. Hey, picture this. A planet that's nothing like the one we know today. No familiar continents drifting lazily across oceans, no bustling cities or sprawling forests as we see them. Instead, think of a time billions of years ago when Earth's surface was a wild, molten mess, cooling into massive land masses that collided, merged, and tore apart like cosmic puzzle pieces. That's the deep-time mystery we're diving into, the story of Earth's oldest crust and the supercontinents that have been hiding in plain sight, or rather, buried under layers of rock and time. It's like peeling back the layers of an onion, each one revealing more about how our world came to be. Studying this ancient crust isn't easy, my friend. Most of it has been recycled through the planet's relentless churn. Subduction zones swallowing old rock back into the mantle, erosion wearing away evidence, and volcanic eruptions overwriting the history. We're talking about rocks that are over 4 billion years old, older than the first flickers of life. But here's where it gets exciting. Recent geological breakthroughs are changing everything. Using seismic waves from earthquakes, tiny zircon crystals that act like time capsules, and even satellite data, scientists are piecing together these hidden worlds. Just this year, in 2025, researchers have uncovered blobs the size of continents lurking in the mantle, and ancient rocks in Canada pushing back the clock on Earth's first stable crust to 416 billion years ago. It's mind-blowing stuff that's rewriting textbooks and making us rethink our planet's wild past. Let's start at the beginning, or as close as we can get. Earth's crust formed about 4.5 billion years ago, right after the planet coalesced from a swirling disk of gas and dust. But the oldest bits we can find today? They're scraps from supercontinents that assembled and broke apart in cycles every few hundred million years. These aren't just big islands. Supercontinents are when most or all of Earth's land masses smash together into one giant hunk surrounded by a superocean. The cycle, assembly, stability, breakup, drives everything from climate swings to the evolution of life. And the hidden ones? They're the earliest, the ones lost to time, but now being unearthed through clever science. The oldest suspected supercontinent is Vaalbara, a name that sounds like something from a fantasy novel, but it's real, or at least the evidence points that way. Around 3.6 to 2.8 billion years ago, during the Archean Eon, Vaalbara might have formed from two ancient cratons, Kap Vaal in southern Africa and Pilbara in Western Australia. Cratons are the stable, ancient cores of continents, like the granite heart of North America or the shields in Scandinavia. Vaalbara wasn't huge by later standards, but it was a pioneer, emerging when Earth was still hot and hostile, with oceans possibly boiling and atmospheres choked with methane. Why hidden? Well, most of its rocks have been eroded or subducted, but matching geological features, like identical ancient lava flows and mineral deposits, link those distant cratons today. Imagine standing on what was once a unified landmass, now split across oceans. It's a reminder that Earth's surface is always in motion even if we can't feel it. Not long after Vaalbara started breaking up, another contender appeared, This one's even more elusive, proposed around 3 billion years ago. Might have included parts of modern India, Madagascar, and Western Australia, bits that later got incorporated into bigger supercontinents. It's like the quiet ancestor in your family tree, not flashy but foundational. Evidence comes from ancient rocks with similar ages and compositions, hinting at a landmass that survived multiple cycles without fully disintegrating. Orr's story shows how these early supercontinents weren't just temporary. Some pieces persisted, building blocks for what came next. Then comes Land, around 2.7 to 2.1 billion years ago, a beefier version that gobbled up Vaalbara's remnants plus other cratons like those in North America and Scandinavia. This was during the Paleoproterozoic, a time of massive changes. Earth's atmosphere started oxygenating, thanks to cyanobacteria pumping out O2. Kenorland's assembly might have triggered huge mountain-building events, or orogenies, like the Kenaran orogeny that gives it its name. When it broke apart, it could have influenced global cooling, maybe even snowball Earth episodes where the planet froze over. Hidden? Absolutely. Its traces are in scattered greenstone belts and ancient sediments, but piecing it together requires detective work with isotopes and magnetic data from rocks. Fast forward to Columbia, also called Nuna, which formed about 1.8 to 1.5 billion years ago. This was a true heavyweight, incorporating most of Earth's continental crust at the time, from Laurentia, North America, to Baltica, Europe, and beyond. Columbia's era saw the first hints of complex life, with red beds, iron-rich sediments, indicating rising oxygen levels. But why call it hidden? Much of its interior is buried under younger rocks, and its breakup scattered pieces far and wide. Recent studies using Zircon ages show peaks in mineral formation during its assembly, linking it to massive igneous events. It's like Columbia was the blueprint for later supercontinents, setting patterns in mantle convection that still echo today. Rodinia takes the stage next, assembling around 1.1 billion years ago and lasting until about 750 million years ago. This one's quirky. Unlike others, it might have formed through extraversion, where continents flipped outward after a breakup. Rodinia centered around Laurentia, with Australia, Antarctica, and India hugging its edges. Its breakup coincided with the Cryogenian period's ice ages, possibly because rifting released greenhouse gases or shifted ocean currents. Hidden aspects? Rodinia's mountains eroded massively, but clues linger in matching rift valleys and ancient glaciers. And get this. Some think Rodinia's remnants influenced the Cambrian explosion, that burst of life diversity around 540 million years ago. Pangaea was short-lived, around 560 million years ago, a transitional supercontinent that's debated but backed by mountain-building evidence and sea level changes. It paved the way for Gondwana and Laurasia, which merged into Pangaea about 335 million years ago. Pangaea is the famous one. Dinosaurs roamed it, coal formed in its swamps, but even it hides secrets, like how its assembly dried out interiors creating vast deserts. But the real hidden supercontinents? They're not on the surface. They're buried deep in the mantle. Recent 2025 discoveries reveal two colossal blobs, or LLSVPs, under Africa and the Pacific, each continent-sized and possibly over 1 billion years old. These aren't just random. Seismic data shows they're denser, hotter regions, maybe remnants of ancient subducted crust from supercontinents like Rodinia or even earlier. One study suggests they're supercontinents in the mantle, anchoring plate tectonics and influencing hotspots like Hawaii's volcanoes. Another found sunken worlds with unknown structures, challenging mantle mixing theories. And Zealandia? That's a hidden continent mostly underwater near New Zealand, mapped fully in 2025, a sliver of Gondwana that's 94% submerged. These discoveries aren't just cool trivia, they have huge implications. Supercontinents drive the carbon cycle, assembly boosts weathering, sucking CO2 and cooling the planet. Breakup releases it, warming things up. Think snowball Earth or the Permian extinction. They shaped evolution. Pangaea's unity allowed species to spread. Its split isolated them, sparking diversity. Even today, mantle blobs might affect earthquakes or mineral deposits. New research pinpoints metal to highways under ancient continents for green tech resources. In North America, geologists found the continent dripping from below, with blobs melting away, hinting at ongoing disintegration. And in Antarctica, a hidden mountain range from 500 million years ago reveals Gondwana's secrets. These findings tie into deep time's rhythm, where supercontinents pulse like a heartbeat, influencing mantle plumes and even magnetic fields. So, what does this mean for us? Earth's not done. Scientists predict a Pangaea, or a new Pangaea, in 250 million years. Understanding these hidden giants helps us grasp climate change, resource hunts, and our planet's future. It's a passionate quest, friend, one that connects us to a 4.5 billion-year saga. Next time you walk on solid ground, remember, it's built on the ghosts of supercontinents, whispering their stories from deep below.